Example 1 says, find the values of the 6 trigonometric ratios for angle alpha in the shown triangle. So the first thing that we want to do is we want to locate our angle, and our angle's happening right here, and our angle is called alpha. And from there, we want to identify which side length has which title. And so this we know is the hypotenuse. If we drew a line from our angle to this side, we know that this is called the opposite length, and then the one that is next to our angle, this is called the adjacent side length. So let's write out the 6 trigonometric functions. We have sine of alpha, cosine of alpha, tangent of alpha, cosecant of alpha, secant of alpha, and cotangent of alpha. And just recall that when we're writing these out, the abbreviations are all 3 letters, but it is an abbreviation for the whole name of the trig function. And if we use our handy mnemonic device, we have Sohcahtoa, and I'm going to start with So sine of alpha is equal to the opposite side length, which in this case is 3, divided by the hypotenuse length, which we actually haven't figured out yet. So one way that we could do that is by using the Pythagorean Theorem. So c squared is equal to a squared plus b squared, which in this case we can call a 1 and b 3. So that's going to give us 1 plus 9, and we get c squared is equal to 10. And then if we take the square root of both sides, we get c is equal to the square root of 10. So that is equal to the square root of 10. Now I'm going to put that in my denominator. Now, recall that we usually don't like to have square roots in our denominator, so we're going to rationalize it by multiplying this fraction by the square root of 10 over the square root of 10, and if we do that, we get 3 square root of 10 all over 10, and so that is sine of alpha. For cosine of alpha, if we follow our mnemonic device, we have Sohcah. So cosine is equal to the adjacent length, which is 1 here, divided by the length of the hypotenuse. And again, we don't want a square root in the denominator, so I'm going to rationalize it. And if I multiply these, I get the square root of 10 over 10. The last part of our mnemonic device says Sohcahtoa. So tangent is equal to the opposite length, which is 3, divided by the adjacent length, which is 1, and 3 divided by 1 we could simplify to just 3. Now, we want to figure out the next 3 trigonometric functions, and cosecant is the reciprocal of sine. So recall this relationship, cosecant of alpha would equal 1 over sine of alpha. And so the way that we could figure that out is by taking the reciprocal. Now, I like to take the reciprocal of the original thing that we found, because if we take the reciprocal of the final product, this thing, then we're going to end up with a square root in the denominator, and we'd have to rationalize again, which you could totally do. It's just going to end up being more work on your part. So the original thing that we got for sine, if we take the reciprocal of that, that is going to be root 10 over 3, and we're done for cosecant. Now secant, the relationship is that secant of alpha is equal to 1 over cosine of alpha, and Earlier we established that cosine of alpha was equal to 1 over the square root of 10. So if we took the reciprocal of that, that would be the square root of 10 over 1, which is the same thing as just the square root of 10. I'm going to move the cosecant over so that it's in line with the other answers. And then lastly, cotangent of alpha is equal to the reciprocal of tangent. So cotangent of alpha is equal to 1 over tangent of alpha. And that is just by definition of the trig function. So I'm just following the definition, and I'm going to take the reciprocal of tangent, which is going to be 1 over 3. And again, let me move that over. So 1 over 3. So those are our 6 trig functions for this specific right triangle.